So these are some questions sent by Anurag Sur, Holy Cross, Agartala, from the chapter Current Electricity of class 10. As we all know, the board exam of ICSE is coming near. So let me try to solve these problems and doubts. I was quite busy in the JEE mains shift of the class 12, for which I got delayed by a little while solving these numericals. So it is now 12:45 a.m. in the night, and I've set for solving these things. Okay, let's proceed. So this question begin with 8b. The potential at a point is 20 volt. Calculate the work done to bring a charge 1 coulomb from infinity to this point. At any point, suppose the point's name is A. Suppose, just a second. Suppose there is a point, whatever the point is, point A. You say that the potential at this point V is given as 20 volt. Okay. Calculate the work done to bring a charge of 1 coulomb from infinity. Suppose this point is our infinity. From infinity, we bring a charge to A, and the charge is given as 1 coulomb. So we are asked to find out what is the work done in bringing the charge of 1 coulomb from infinity to A. There is a direct formula to calculate this thing. The formula states that work done is equal to charge into potential difference. Or in other words, you can also say potential at any point A is work done in bringing a charge, work done bringing charge from infinity to A divided by per unit of charge. So the potential it is given as 20 volt. Work done we need to calculate, and the unit of the charge is 1 coulomb. So work done follows as 20 multiplied 1 is equal to 20 joule. This formula generally we do not see in the class 10th level. This belongs to chapter 2, electric field and potential of class 12, where we basically talk about these things, potentials. Here we talk in much more details. The actual formula is given as V at any point A minus V infinity. Okay, fine, let me state in some better way. It is stated as potential difference is equal to V final minus V initial is equal to work done in bringing a charge from initial position to final position per unit of the charge. So here the V final is V at infinity and V initial is V at infinity, from where we are bringing the charge in between the minus sign. Work done in bringing the charge from infinity to A, because infinity is our initial position from where we are bringing the charge. A is the final position where we are bringing the charge, divided by V at A is given as 20, and V at infinity we assume to be as 0 volt, and work done from infinity to A we are asked to calculate, and the given charge was of 1 coulomb. So work done to bring the charge from infinity to A is equal to 20 multiplied by 1 is equal to 20 joule. That is the better interpretation, but it requires some knowledge from class 12 which is not done in class 10 level. Okay, this is the answer. Welcome to EASYICS, where I try to make physics easy. Okay, now let's go to the next question, question number C. See, we are having some beautiful circuit. First of all, let me draw the circuit in the beginning and we'll be proceeding towards reading the question. I can see 8624. Okay, fine. The circuit is given something like 3 ohm at the top, 6 ohm at the bottom. 3 ohm, 6 ohm, and in between we are having some more resistances. 8, 6, 2, and 4. This is 8, this is 6, this is 2, and this is 4 ohm. Okay, and it is connected to 1.8 volt battery. Okay, so what does the question read? The question reads that calculate the current through the 3 ohm resistor. That means we are asked basically to find the current through this 3 ohm resistor. The EMF of the battery is 1.8 volt and internal resistance is negligible. Okay, so basically we need to talk about the current through this 3 ohm resistance. The given potential difference across the cell is 1.8 V. We need to calculate the current through 3 ohm resistor. Okay, fine. Now the given circuit actually appears little bit complex. Thing is not complex. The thing is about our thought process. Let us try to break the circuit and make it easy so that we can have an easier solution. Just say me one thing. This part of the circuit, I hope this is visible. Just a second, let me change the color. This part of the circuit, this part of the circuit, that is the 3 ohm resistance where it is sitting, this part is entirely in parallel with the remaining part of the circuit. This part is in parallel with the remaining part of the circuit, right? I can break the circuit in this way. Just a second. This part is in parallel with this part of the circuit, and here we are having the battery. Now, if this part and this part are parallel, both of them are going to have the same potential difference, because we know in parallel potential difference is always same. So the branch having the 3 ohm resistance will have a potential of 1.8 volt only. Am I clear? This branch parallel. Total potential is 1.8 volt. As because this branch and this branch is parallel, so potential of this branch will be 1.8. Potential of this branch will also be 1.8 only. Because in parallel, potential remains same. So if the potential through the 3 ohm resistance is 1.8 volt, resistance we know as 3 ohm, to calculate the current will be applying V is equal to IR, which is called the Ohm's law. And from here I can say I is equal to V upon R, and V is our 1.8 and R is 3. So the current will be 0.6 ampere through the 3 ohm resistance. Okay, fine. Let's get into the next numerical. It says that the battery of EMF 16 volt. Okay, EMF, not potential difference. And internal resistance of 2 ohm is connected to two resistors 3 ohm and 6 ohm connected in parallel. So in physics what we do is the moment we come through a question, we read it, we understand it, the picture forms in our brain, and we draw the picture in the beginning. Half of the job is done here only. So the internal resistance, these are 3 ohm and 6 ohm battery resistance connected to EMF The EMF is given as 16 volt and the internal resistance is given as 2 ohm. Our diagram is complete. EMF is 16 volt, internal resistance written in smaller is given as 2 ohm, and one resistance is 3 ohm, the other resistance is 6 ohm, and they are in parallel. Okay, find the current through the battery. Okay, you need to find the current that is coming out through the battery at API. The potential difference between the terminals of the battery. Okay, this is the positive and the negative terminal, the potential difference. Remember, we are given the EMF. We are not given potential difference. We are asked to calculate the potential difference. The current through the 3 ohm resistance, the current in the 6 ohm resistance. Okay, so many of questions, let us solve one by one. So getting to question number 1, let us in the beginning solve for the equivalent resistance of the circuit. Now there is a shortcut. If 3 and 6 ohm, and this is and are in parallel, equivalent resistance is always is equal to 2 ohm. How? Okay, in parallel equivalent resistance will be given as 1 by 3 9 by 18. So from here we can say R equivalent is equal to 2 ohm. This is how we get it. But 3 and 6 combination of these two resistance in parallel is one of the favorite combinations of the question setters in class 12 also, in JEE and NEET level also. To remember, 3 and 6 in parallel, equivalent is always 2. Okay. By the time you will be solving, your friend will be solving all those things. By that time, you will be done with the numerical, writing it 2 only. Anyways, we need to find the current to the battery. You have to find that is the equivalent resistance of these two resistors. What will be the equivalent resistance of the entire circuit? The equivalent resistance of the entire circuit will be, and the circuit will be equivalent resistance of the two resistors 3 and 6 plus internal resistance, because we know external resistance and internal resistance always in series. It came as 2 and it is given as 2. The total resistance, effective resistance of the circuit is 4 ohm, no doubt in that. Fine. So we're asked to find out what is the current coming out of the battery. We'll be applying V is equal to IR, which is the Ohm's law. What is the EMF given? The EMF is given as 16 volt. Current we need to calculate. Resistance just came out as 4. The battery gives a current of 4 ampere. That is question number A solved. Okay, what is the part B? The part B was, I guess, the potential difference between the terminals of the battery. What is the difference between EMF and potential difference? Okay, EMF is always measured when the circuit is open. Potential difference is measured when the circuit is closed. For example, you purchase a battery from the market. It is written it is a 12 volt battery. The battery is not fixed in the circuit as of now. That means what? The battery is in open circuit. This 12 volt is the EMF. When this battery is put in a circuit, we don't get 12 volt only in the circuit. Come again. We purchase a battery from the market. On the battery, it is written 12 volt. It is a 12 volt battery. But whenever we'll be putting this battery in the circuit, the battery will never deliver 12 volt. It will always deliver less than 12 volt. For example, it will be delivering 9 volt. Always. 9 volt is just a fictitious figure to make you understand that the potential difference we are getting actually is less than the one which is printed. The printed level is the EMF, and what we get actually in the real circuit is the potential difference. So 3 volt is lost somewhere. We discussed these things in class 12. So when the charge actually, for example, this is the wire getting into the battery and this is the wire coming out of the battery. Current comes out in this way. The current travels throughout the circuit and gets into the battery. So when the current, that is the electrons, are crossing through this battery, inside the battery are the electrolytes. The electrons needs to fight against these electrolytes to come out of the battery. So part of the printed 12 volt gets lost or used by the electrons while overcoming this electrolyte distance. So this 3 volt is consumed here out of the 12 volt and we get delivered as 9 volt. So this 9 volt is the potential difference in the circuit and EMF is the potential difference in the open circuit. That is the difference. Anyways, this is nowhere relevant to a numerical. Out of curiosity, I just mentioned it. So EMF is given as 16 volt. We need to calculate the potential difference. By this time, we know that potential difference will be definitely less than EMF. It is whatever the answer of potential difference will be, it will be less than 16 volt. Now let us check for it. I'm still new using these things. I don't know how to add a page. Mm, fine. Okay, fine. I got it. Just a second. I will successfully and adding a page. There is an option of deleting page. So easy. What is the option of getting? Adding page. I don't know. I guess I got it. Yeah. So, so we are on the way to calculate the potential difference, which is obviously going to come less than EMF. Okay, fine. So we'll be obviously using the Ohm's law. V is equal to IR. V is the potential difference. What was the current running in the circuit? The current in the running in the circuit, we calculated it as the 4 ampere. And what was the equivalent, entire equivalent of the circuit? It was 4 only, right? It was 4 only. But if you do in this way, you will be doing a mistake. So let us learn how to do in the correct. You are going to calculate the potential difference of the battery. Find the potential difference between the terminals of the battery. We are going to calculate the potential difference just between the terminals of the battery. And this is your battery. EMF is equal to 16 volt and the internal resistance, I guess it is given as 2. So you will be applying V is equal to IR above these only. So V is equal to what is the current coming out of the battery? It is 4 ampere. And what is the resistance of the battery? That is 2 ohm. So this V is equal to 8 volt is the potential difference across cell. Here you calculated using the equivalent resistance of the circuit. See, you are getting what? V is equal to 60 volt, which is the given EMF. So don't do such mistakes. You are asked to calculate the potential difference between the terminals of the battery only. So you'll be using the current coming out of the battery and the resistance of the battery in Ohm's law. V is equal to IR. Remember that. See, our EMF was 16. Potential difference came out as an 8, which I already told. EMF will be more than the potential difference. If this one is okay with you, let's go to the third part of the question, which says the current in the 3 ohm resistor. Okay, fine. Let me draw the circuit once again. This was the 3 ohm resistance and this was the 6 ohm resistance. The current we were getting was 4 ampere, and it was 16 volt battery, internal resistance 2 ohm. Potential difference we got is 8. Okay, so we're asked to find the current in this 3 ohm resistance, right? Okay, fine. Say me one thing, as because these two resistances are in parallel, both of them will be having the same voltage. It is the same potential difference, right? What will be the potential difference it will be getting? Don't say it is 16 volt, they will be getting 8 volt, because in the circuit we are getting how much? 8 volt only, closed circuit. 16 was supposed to give in open circuit. That is the EMF. That is the potential difference, right? So both this 3 ohm and 6 ohm resistors gets a voltage of 8 volt and not 16 volt. 16 volt is the capacity of the battery. 8 volt it actually supplies. The remaining 8 volt is consumed by the current when it crosses the battery, already discussed, right? So the voltage through the 3 ohm is 8 volt, resistance is 8 volt. So now you can easily calculate the current from Ohm's law. V is equal to IR. So current through the 3 ohm will be voltage of the 3 and resistance. And what is the voltage? 8. And what is the resistance? Resistance is 3. So current through the 3 ohm resistance is 8 divided by 3. It will be something 2.66, 2.67 recurring ampere. Clear? Okay. The next part is current in the 6 ohm resistor. You can easily calculate the current in the 6 ohm resistor in the same process. The 6 ohm resistor, resistance is 6 ohm. It will be having a voltage of how much? 8 volt, as because battery is giving 8 volt in the closed circuit. 3 and 6 in parallel, so both 3 and 6 receives 8 volt. So it will be, current will be given by Ohm's law. V is equal to IR. Voltage is 8, current is resistance is 6, it will be 4 by 3, and the current through the 6 ohm resistance will be 1.33 ampere. Simple. Clear? Okay, now let's get into the next question. Okay, I can see it is a huge one. Okay, I've added sufficient pages. The circuit diagram shows three resistors, 2 ohm, 4 ohm, and R ohm, connected to a battery of EMF 2 volt. Okay, internal resistance 3 ohm. The mains current is flowing as 0.25. Very fine. We are asked to find out the potential difference across the 4 ohm resistance. The potential difference across the 4 ohm resistance. Potential difference across the 4 ohm resistance. Okay, the potential difference across the internal resistance. So let me draw the internal resistance here only as 3 ohm. We are asked to find out the potential difference here also. Potential difference across R, potential difference across 2. Okay, fine. They have said potential difference across the R or 2. R and 2 are in parallel, so both of them will have same potential difference only, no doubt in that. And finally, you are asked to find out the value of R. Okay, so many things to do. Let us do one by one. Question number A. Potential difference across the 4 ohm resistance. Potential difference across the 4 ohm resistance. Now, say me one thing. What is the current in the entire circuit? Current in the entire circuit is 0.25 ampere. Right? Okay. Now, as because this part, and this part of the resistances are in series only, each of them will be having similar current. If current is I through them, current will be I through it, current will be I through it, and the current in the circuit is 0.25. So current in this combination will be 0.25. Current here will be 0.2. Current here will be 0.25. Current here will be 0.25. So I got that current in the 4 ohm resistance will be what? 0.25 only. Resistance is given as 4 ohm. You can easily calculate the potential using Ohm's law. V is equal to IR. I is 0.25. Resistance is 4. The answer will be 1 volt. Clear? Okay, next part. Option B. Potential difference across the internal resistance of the cell. The same way you can calculate the potential difference across this 3 volt, 3 ohm resistance. V is equal to IR. What will be the current through this one? Internal resistance. The internal resistance always stays in series with the circuit resistance, and the circuit current is 0.25. So the current through the internal resistance will also be 0.25. And resistance is given as 3 ohm. The answer will be 0.75 volt. That is the answer. Now the student has marked this one as very important. Let us see. Find the potential difference across the. Let me draw the diagram here again. It will be easier to understand both for me as well as. So this is the given circuit, and this one is 2, this one is R, this one is 4, this one is 3, and this one is 3 volt, 3 ohm, 4 ohm. The current is 0.25 ampere. Okay, and these are the things we are given. Okay. So you're asked to find, question number C was potential difference across the this or this. So potential difference across both 2 and R will be what? Same as because they are in parallel. Okay, fine. So what is the potential? What is the potential difference the battery is supplying? V total 3 volt. Tell me one thing. This out of this 3 volt, that's a second. Out of this 3 volt, this part will consume some of the potential. Then this part will consume some of the potential. Then this part will consume some of the potential because the potential is consumed by the circuit so that the current can pass through the circuit. This is one circuit element, this is another circuit element, this is another circuit element. Three of them will consuming the potential which is coming out of the battery and is equal to 3 volt, right? Okay, then we are asked to find out what is the potential consumed by this one. The potential consumed by this one will be total potential minus potential consumed by this 4 ohm resistance plus potential consumed by this 3 ohm resistance, right? The total potential will be consumed by this combination, this one and this one. Or in other words, you can say the total potential is equal to the potential consumed by this one, and this one. Total potential is how much? 3 volt. And what is the potential consumed by this 4 ohm resistance? Just now we have calculated it is 1 volt. And potential consumed by the internal resistance, just now I calculated it is 0.75 volt. So it is 3 minus 1.75. Both the internal battery is having 3 or 2. Okay, 3 minus 7.5, it will be 1.25. That's it. Have I done any mistake, calculation mistake? Let me check for a while. I'm extremely sorry. The battery is having a voltage of 2 volt only. So this will be 2 volt. 2 volt, 2 volt, and it will be 2 minus 1.75, 0.25 volt. It is having 2 volt, not 3 volt, as given in the question. 2 volt. Battery is giving 2 volt. A part of the 2 volt is consumed by this combination, and this combination. This combination was consuming 1 volt. This combination, this one is consuming 0.75. So the potential consumed by this one will be 2 minus 1 plus 0.75, that is 0.25 volt. Clear? That was a mistake I did in writing. I wrote 3 volt in place of 2 volt of the entire battery. I rectified my mistake. Okay. So that is the potential that will be consumed by the combination of 2 and 3. So both 2 ohm will consume 0.25 volt. R ohm will also consume 0.25 volt because they are in parallel and hence they will be having the same potential. Clear? Okay. The value of R in the last part of the question we need to solve for. Value of R. Say me one thing, what will be the equivalent resistance of this part? What will be the equivalent resistance of this part? The equivalent resistance of this part will be 2R by R by 2. Or 1 by R equivalent is equal to 1 by 2 plus 1 by R. 1 by R equivalent is equal to 2 pi R by 2 pi. 2 plus R by 2R. The next step, we just invert the reciprocal. We get the answer 2R by R plus 2. Okay. What is the potential consumed by this combination? It is 0.25 volt. What is the current getting inside this combination? It is 0.25 ampere. It is given in the question. The circuit receives a current of 0.25 ampere. As because this part are in series, all of them will be having the same current. So this combination also has 0.25 current. If I apply now Ohm's law, V is equal to IR, I can write 0.25 is equal to 0.25 multiplied to R by R plus 2. It will be cancelling out each other and will be having R by 2 R plus 2 is equal to 2R. 2 is equal to 2R minus R, or R is equal to 2. That was the unknown resistance. Clear? Okay, the next question, 29. The time is now 1:17 a.m. I'll be not editing this video. I'll be uploading the raw version of this video only because पता ही नहीं edit करते कैसे सच्ची तो ये है चलो कोई नहीं करते the raw video. This way we can also align the way a teacher thinks and teacher is doing, and I'm little bit of hurrying up while doing because it is already midnight. I'll have to complete this thing. I have to upload this thing. It will take some 1 or 2 more hours. I'm in class from 7:30 a.m. in the morning, so altogether I'll be sleeping only some 5 hours. So I'm hurrying up a little bit. Actually, sorry, I'm hurrying up a little bit. I hope it is not a problem. आराम से करा रहा हूँ इतना भी क्या जल्दी करा चलो. The next question comes 29. 3 resistors. How many questions we are still having to go? 29, 30, 55, 56, 59, Okay, up to 59. Type questions more to go. Let's not waste time and get into it. Three resistors of 6 ohm, 2 ohm, and 4 ohm. 6 ohm, 4 ohm, and 2 ohm are connected in the ammeter, joined to an ammeter A. Okay, and a cell of EMF 6 volt. Okay, in the figure. Find the effective resistance of the circuit. Okay. Let me try to draw the circuit once again. I'm not drawing the ammeter. Let me name this part as A, B, C, and D. Okay. Now I'm saying one thing here. AB and BC will be in series. If I say that, will you agree with me? And BC and CD will be again in series. And this branch, and this branch will be in series. And their combination will be in parallel with AD. Okay, now I'm going to say why. For example, let me consider from this battery a current is coming out. Suppose I current is coming out. The current I will be traveling here, will be reaching this junction, right? Now from this junction, the current will be getting splitted into two branches. A part of the current goes here, a part of the current goes in this branch. Let me consider this part of the current is I1 and this part of the current is I2, which is getting in this direction. This is I2 and this is how I1 is traveling. This is how I1 is traveling and this is how I2 is traveling. Now tell me one thing, we know that in series current remains same. I1 will be traveling from A to B. From B it will be turning downward and travel to C as because there is no other obstruction. From C it will now travel to D. So both AB, BC and CD having the same current. If current is same through some resistor, we say the resistors are in series. That is why I said AB, BC, AB, BC, CD will be in series, right? Now the current in AD is I2, which is different from I1. When the current is different in two branches, current is different in two branches when the two branches are in parallel. Because in parallel, voltage remains same, current becomes different. So if current I2 is different from the current I1 here, obviously A, B, B, C, C, D, which are in series, will be all together in parallel with my branch AD, right? In that case, what will be the equivalent circuit? AB plus BC plus CD, they will be equivalent. Okay, fine. AB is having no resistance only. If AB is having no resistance only, the resistance is only in BC and CD part. I'm sorry. I consider AB also as having some resistance. Okay, fine. If the question was something like that, this AB part is also having, this part is also having some resistance. So this, and this will be in the same in the series only, right? Anyways, it is a good luck thing that this part is not having any kind of resistance, so not an issue. So in that case, we will be writing what? We'll be writing a BC and CD will be in series. That much will be sufficient. BC and CD will be in series and it will be in parallel with AD. That mistakenly took that AB is also having some resistance. So BC having I1, CD having I1, both of them will be series, and BC is given as 4 and CD is given as 2. The resistance will be 6 ohm. And R1 is having a resistance of 6 ohm. Now this is in parallel with AD, and AD's resistance is 6 ohm. So 6 and 6 are in parallel, right? The equivalent resistance will be 1 by RE is equal to 1 by 6 plus 1 by 6. RE is equal to 6 by 2 is equal to 3 ohm. Always remember, if there are two or more than two resistances in parallel, the equivalent resistance is given as the resistance value divided by the number of resistances in parallel. So here R is equal to 6, and the number of resistance in parallel is 2. 2 guinea 6 and 6 are in parallel, so 3 ohm. That is the answer number A, 3 ohm. What is the reading of the ammeter? And obviously, what does an ammeter read? Ammeter reads current. Ammeter measures current. The current will be given as Ohm's law. What is the voltage of the circuit? 6 volt. And what was the equivalent resistance? 3 ohm. The ammeter will be having a reading of 2 ampere. Clear? Okay. Question number 30. What does the question say? Diagram below there shows the arrangement of 5 different resistances. Resistance 1, resistance 2, 3, 4, 5. Okay. And battery is having some EMF of 1.8 volt. Find the total resistance. So these two resistance will be in parallel. These three resistance will be in parallel, and the combination of these and these will be in series. That's simple. So let's talk about the R1 and R2 in parallel. So what will be the combination of this one? Suppose 1 by R equivalent 1 will be 1 by 10 plus 1 by 40. So 40 plus 10 multiplied LCM 40 into 10, 50 by 400. So our equivalent 1 will be 400 divided by 50 is equal to 8. Now R3, R4, R5, they are also in parallel. So R equivalent 2, let us name them. It will be 1 by 30 plus 1 by 20 plus 1 by 60. Okay, 1 by R equivalent to let us combine 1 by 30 and 1 by 60, and it will be 1 by 20. If we take common 1 by 30, it will be 1 plus 1 by 2 plus of 1 by 20, and it will be 1 by 30 into 3 by 2 plus 1 by 20. It will give us 10. It will be 1 by 20 plus 1 by 20, 2 by 20, 1 by 10. Therefore, R equivalent to came as 10 ohm. Now R equivalent 1 and R equivalent 2 in series. So final equivalent will be R equivalent 1 was 8 ohm. right? This combination and this combination will be in series. This is our R equivalent 1. This is our R equivalent 2. They're in series. Okay. Reading of the ammeter is a very easy part. The ammeter will again reading. We have give the reading of the current. Current will be given as V upon R equivalent, and V of the circuit is given as 1.8 volt, and the total R equivalent is coming out as 18. So the current will have a reading of 0.1 ampere. Okay. 55 number question. I guess it is the second last question, right? 55, 56, 59. Oh, third last question. We have three more numericals. Okay. A cell of EMF 1.5. There are also four questions given in EMF. Let me draw the circuit. The EMF is given as 1.5 volt. Internal resistance is 1 ohm. This external 2 resistance 4 ohm and 2 ohm respectively. We are asked to find the current in the circuit. For calculating the current in the circuit, we'll be applying V upon R equivalent, and V is given as 1.5. Now we need to take we'll have to calculate R equivalent. Now say me one thing, this 4 ohm, 2 ohm and 1 ohm, these three resistances are always in series because this is an external resistance, and external resistance is always in series with the internal resistance. It will be 4 plus 2 plus 1. Right or wrong? Oh, it is 20, I'm sorry. Then it's 20 ohm. 20 ohm. It will be obviously 1.5 by 4 plus 20 plus 1. It will be 1.5 upon 25. 3 5s are 5 5s is equal to 3 by 50. And 3 by 50 will be how much? 3 by 5 into 1 by 10. 3 by 5 is 0.6 divided by 10. It will be 0.06 ampere. Okay. Next part is find the potential difference. Potential difference across the 40 ohm resistance. 40 ohm, which is 40 ohm. Oh, sorry, 4 ohm resistance. The dots are potential difference across the 4 ohm resistance. Fine. So, what is the current we got in the entire circuit? Current is 0.606 ampere. So, what will be the current through the 4 ohm resistance? The current is flowing out as current is 0.0446 or 0.06 ampere. That's because 420 and this internal are in the series, all of this resistance will be having the similar current only. The current of this 4 ohm will be what? 0.06. Right? So V is equal to IR will be applying Ohm's law. Current through the resistance is 0.06 and the resistance is given as 4 ohm. The answer will be 0.24 volt. That is the potential difference across the 4 ohm resistance. Okay. Third part of the question, voltage drop across internal resistance when current is flowing. That means we need to talk about the potential difference in the internal resistance. Okay. Again, we'll be applying Ohm's law. V is equal to IR. Voltage drop. What is the current of the internal resistance? Internal resistance is in series. The current in the circuit will be the current in the internal resistance 0.06. And what is the internal resistance? Internal resistance is 1 ohm. So V is equal to 0.606. This is the potential drop of the internal resistance, right? And the potential difference across the cell we need to calculate. Okay, potential difference of the cell. EMF of the cell is given as how much? 1.5 volt. By this time we know the V will be less than EMF. Let us check again. Okay, space constant. I'll be solving out here. There's a formula we know now. R by R is equal to E by V minus 1, where R is the internal resistance, small r is the internal resistance, capital R is the external resistance, E is EMF, V is the potential difference, minus is minus, 1 is 1. So what is the internal resistance here? 1. What is the external resistance here? The external resistance is 20 plus 4, 24, because they're in series. Internal resistance, EMF is given as 1.5. V we need to calculate minus 1, whatever will be coming. This will be the answer. So it will be 1 by 24 plus 1 is equal to 1.5 upon V. So 1 plus 24 divided by 24 is equal to 1.5 upon V. 25 by 24 into 1.5 is equal to 1 by V. So V is equal to 24 into 15, 25 multiplied by 10. 10 comes because of the decimal, right? Where to calculate? Should I add one more page? Okay. So it is what? V is equal to 24 into 15 divided by 25 upon 10. First, see the traditional way of doing the numerical, then I'll show a shortcut also. 35550, right? Anything else? 12 to the 24, 5 to the 10. It is 36 upon 25. And now it is a little bit trickier to solve and get the decimal. 36 upon 25. Okay, fine. Now let us try to do in the tricky way. In this line, what we got is 1 by V is equal to 25 multiplied 24 into 1.5. We just reverse, it will be 24 into 1.5 by 25. Now if I split this way, can I write 24 into 1.5 as 1 plus 0.5? I guess yes. It comes up to be 24 into 1, 24 plus 24 into 0.5, that means half of 24, that is still, that is 36 by 25. So this is an alternative way to solve for the same thing, to avoid this kind of kattam kuttam kill. Okay, okay, in any form you have to calculate 36 by 25, there is no escape. So 36, it will be 25 divides 36 of 1, it will be 9. 25, 36, 36, 25, 11. If it is 11, 25 4 is 100. Again 1, it will be 100, something like that. 1.44. Okay, anything remaining? No, I guess not. Potential difference. See, the potential difference again comes at 1.44 volt. EMF was 1.5 volt, and the potential difference came as 1.44 volt. This is less, right? Okay. Second last numerical. In the figure given below, the ammeter reads 0.3. If the ammeter is reading 0.3, the current in the circuit is 0.3 ampere. As simple as that. The battery combination is given here and it is reading as 6 volt. So potential difference is equal to 6 volt. The combination of resistance is given R and 16 parallel. The equivalent will be 60 into R by 60 plus R, because 60 and R are in parallel. That is the data we are given. So we are asked to find out the total resistance of the circuit, right? Okay, let us talk about the total resistance of the circuit. Total resistance of the circuit will be applying V is equal to IR. V is question number 1. V is given as 6 volt. I is given as 0.3 and R we are asked to calculate. R is equal to 6 upon 0.3. Obviously R will be 20 ohm. Okay, R will be 20 ohm. Don't confuse this R with this R. This is the total resistance of the circuit, RT. Now, second will be the value for second part of the question. What is the total equivalent resistance of the circuit? Equivalent resistance is 60R by 60 plus R. And just now we calculated the equivalent is, or the total is 20 ohm. So from here we get a relation and we can easily calculate. So if we do this thing, we'll be having 3R is equal to 60 plus R. 3R minus R is equal to 60. 2R is equal to 60. So R is equal to 30 ohm. So the unknown resistance is 30 ohm. Third part, the current flowing through R. Okay, that one is interesting. Current flowing through the 30 ohm resistance. So diagram is what? The diagram says this is the diagram. R was 30 and this is 60. The battery was 6 volt and the current flowing in the circuit is 0.3 ampere. That is the diagram given. Now we are asked to find out the current in here, current in this much. Now tell me one thing, as 30 and 60 are in parallel, they will have the same potential difference, right? So the potential difference of both 30 will be 6 volt and 60 will be 6 volt. 6 volt is the battery potential. 30 and 60 in parallel. Both the resistors will have potential of 6 volt. Right? Okay. So what will be the current through the 30 ohm resistance? We have to find out. So what is the current through the 60 ohm resistance? Let us apply Ohm's law. V is equal to IR. For they have asked now to find the current only through the 30 ohm resistance. We will be calculating current from both 30 ohm as well as 60 ohm. Chalo, ek ke saath ek free. So first of all, we will be calculating for the 60 ohm resistance. For the 60 ohm resistance, potential is 6. Current you do not know. Resistance is 60. So obviously current will be 6 by 60 is equal to 0.1 ampere. That is the current through the 60 ohm resistance. Total current is how much? 0.3. So what is the remaining current? Current remaining 0.3 minus 0.1 is equal to 0.2 ampere. So this remaining current will flow through which resistor? There is no other resistor apart from the 30 ohm resistance. This is the current through 30 ohm resistance. Clear? Okay. The last numerical of this session. It has been already 1 hours. 1 hour, not hours, I know. 4 cells, each of EMF 1.5 volt and internal resistance 2 ohm are connected in parallel. Okay, there are 4 battery, no, 4 cell. What is battery? You know, battery is combination of cell, 2 or more cell combined to form a battery. So here we are having 4 cells, each of EMF 1.5. They have not mentioned anything about the polarity, so we consider all the cells having same polarity. Now, what is the polarity? If you know, you know, or else I will welcome you in class 12 with this concept. Same polarity means all the positive poles or the negative poles in the same direction. This is same polarity. Each of the EMF was 1.5, 1.5, 1.5 volt, and 1.5 volt. Okay, and resistance 2 ohm, 2 ohm, 2 ohm, and 2 ohm. They are connected to an external resistance of 2.5 ohm. Okay, we are asked to find the total resistance of the circuit. The total resistance will be obviously the resistance of the cells plus the resistance of the circuit, external resistance, that is 2.5 ohm. So all cell in parallel. So what will be the equivalent resistance of the cell? Just now I told, if there are some n number of resistances in parallel, the equivalent, and each resistance if is equal, then the equivalent is given as the value of the resistance divided by the number of resistance. The value of the resistance is here 2 ohm, number is 4 ohm. It will be 0.5 ohm, and the external resistance is 2.5 ohm. So what will be the equivalent resistance of the circuit? We know that external resistance and the internal resistance is always in series. It will be 2.5 plus 0.5 is equal to 3 ohm. That is the total resistance of the circuit. Question number 1 answered. Second is the current flowing through the external circuit. We'll be applying V is equal to IR. V is given as, okay fine, what is V? Individual cells have potential of 1.5 volt. All cells in parallel, and hence the individual potential of, if all cells is 1.5 volt and all the cells are in parallel, the parallel potential remains same. So the battery is having a potential of 1.5 volt only. So we are writing 1.5 volt is the potential of the circuit. Is this clear? See, all the batteries are in parallel, parallel. So if all the batteries are in parallel, then in case of combination of potential for the battery, the potential remains same. In case of series, the battery potentials would have added up in same polarity or subtracted in reverse polarity. For example, okay fine, I'm showing here. For example, the batteries are in, there are two batteries, plus minus plus minus. See, after plus minus, it is called same polarity. Suppose it is having a potential of 5 volt, 2 volt, equivalent battery potential will be 5 plus 2 is equal to 7 volt. Now this is one battery, oh sorry, one cell, plus minus, and this is another cell, plus minus. See, plus minus, minus plus. It is called reverse polarity. This is called reverse polarity. In such cases, if it is 5 volt, if it is 2 volt, the battery potential will be 5 minus 2 is equal to 3 volt. And if the batteries are in parallel, if this having V and V, total potential will be V only. Okay. So here all of them are having potential of 1.5, 1.5, 1.5 and 1.5. Total potential will be 1.5 only. The current we need to calculate, and R will be our R equivalent, and R equivalent we just calculated of the circuit is 3. So I is equal to 1.5 divided by 3, it will be 0.5 ampere. Third and the last part of the question. Okay, done. The drop in the potential across the terminals of the cell. The drop in the potential across the terminals of the cell. Okay, but as because all the batteries, sorry, all the cells are in parallel only, the drop in potential of the entire cell structure is equal to the drop in potential of single cell only. Again, alright, yeah. All the cells are in parallel. The drop in potential across the terminals of all cells will be what? Equal only. Let us calculate for one. Just now we told about a relation R by R is equal to E by V minus 1. R is what? Internal resistance of only one battery, right? Internal resistance of the circuit, R will be what? R will be equivalent, just a second. R will be internal resistance. The internal resistance will be having R4. We will be writing R equivalent, and capital R is the external resistance. We are having only one only, right? And what is EMF? EMF of all cells are given as 1.5. So 1.5 will stay 1.5 only. We were asked to calculate minus 1. So R equivalent we calculated as internal equivalent, internal resistance equivalent 0.5. External resistance is 2.5. Each cell having an EMF of 1.5 by V minus 1. Just solve for it. What will come? That will be the answer. 5 by 25 is 1 by 5 plus 1 is equal to 1.5 by V. It will give us 6 by 5 is equal to 1.5 upon V. So V is equal to 1.5 into 5 upon 6. And right, what was the answer? 3 5, no sorry, no, it is fine only. 5 3 is 15, 2 3 is 6, it is 25 upon 20. Why to do this thing? 5 by 4. 5 by 4, the answer will be 4 on the 4, 25, 1.25 volt. So that is all about the solution of the numericals provided. I'll be not doing any kind of editing to cut down any of my flaws. It will be entirely raw, and it is approximately 2 a.m. 1:53 a.m. in the midnight. I'm wrapping up at here. Some places I did a little bit of fast to cope up with the time, and I hope it was easy for you. Any kind of problem, any kind of confusion, just let me know. I hope it will not be there. So keep on studying. All the very best.